Hello, YouTube. So tonight we're going to go over some basic ideas for how to create a first pass solution. What is a first pass solution? Anybody?
Oh.
Yes, I'm asking. What is a first pass solution?
Just
it works
one
on the first go.
Yeah.
The first pass solution is the first one you come up with. Is it a good solution?
Maybe.
Not usually.
Yeah. Is it the best solution?
It just needs to work.
Exactly. It's not barely a good solution. It's not the best solution. It is the solution that works. Hopefully. We are not going to start with eating cookies.
Okay.
Oh man.
That is not going to happen. I think single number is the easy one to start with. We start with eating cookies, we'll be there all night. All right. So, if you haven't been in my classes, my sessions before, I ask a lot of questions to you, and then I try and clarify them if you don't understand. I also like to try and get everyone involved in solving the problem. And I also make everybody read as much as I can. So, no wallflowers. So Suzanne, can you please read the directions for the single number?
Sure. So given a non-empty array of integers where every element appears twice except for one, find that single number. You may assume that there will always be one odd number out and every other number in the input shows up exactly twice.
So what do we know about this? So the first part of the Ooper method, we have to understand what we're being asked to do. What do we know with these given instructions? Chime in. So what's the first thing that we know?
That you'll always have a pair.
Right. We're always going to have a pair. So the numbers are either going to be, there's either going to be one or two numbers, right? There's either going to be one or two. Cool.
Right.
What's the next thing that we know?
One odd number out.
Yeah.
Right. There's only going to be one. So if the number appears only once, okay. The one that only appears one time is the one. All right. Let's look for some edge cases. What else do we see?
Non-empty array, so it's always going to be something inside.
There's always going to be something inside our array. There's always going to be something inside our array. Our numbers come in pairs, so it's either going to be one poor lonely single person or all the happy couples. Those are our only two options. There's not going to be 3 2s, there's not going to be 4 2s, there's not going to be 82 2s and 1 1. It's going to be pairs or one number. All right. So, with that, let's start doing some thinking.
My first thought is just making a stack.
All right.
Yeah.
So let's implement that. So let's define our function and
It'd be this one right here, right?
Mhm.
So my thought is just like make a stack, and then for chart and array, just probably add whatever number comes in, and then if the next iteration matches whatever is in the stack, you could remove it. But now I'm thinking about it, maybe a dictionary might work better instead of an array.
I like that.
So char.
Oh, we need an if there. So if, are you trying to say if the character's in the stack?
Yes. And then
So if character stack is true. I don't know what language you're coming from, but I'll see an if there.
well, this is just to add it to the
Alrighty.
stack. And then I guess
Oh, okay. You're initializing it with a Boolean.
yeah. now I guess. Okay.
How about we initialize it with a number? With 1.
1. Okay.
Mhm.
So I guess I need to check if the stack is empty first, right?
No, the character's memorized? Yeah. Well, no, I don't think you have to check if the stack's empty, do you? You instantiate it as empty.
Yeah.
But you should check if the character is in the stack.
Okay. So if char and stack, then I would remove.
But isn't that taken care of with 7? Because you're only doing it if char is in. Oh, okay, I see what you're doing in stack. I'm sorry. Continue.
Stack character equals plus equals 1. So increase your so you can just increase that by 1. So if it's there, you can increase it by 1. Else add it to the stack. Stack character equals 1.
Cool.
All right, that seems pretty good. And
then finally return whatever is left over, because that should be the last thing in there.
Well, this is, you've made a wonderful
Actually,
dictionary.
yeah.
So you haven't removed anything from the array.
Right, yeah.
And you haven't done this. So it looks like you might have to do another for loop to look through the
Right.
stack.
So I think I do. So if they are matching, their value would be 0.
So if
So
they're
whatever-
matching, the value would be 2. 1 plus 1 is 2.
2, yeah, 2. So whatever it is left over is just 1. So for whatever is in the stack, if it has a value of 1, then return the key of that stack key value.
Okay, that sounds pretty good.
Return stack. Yeah. What is it? Dict that key, no values is equal to 1. Then return keys, something like that.
That would return all the keys.
All of them. I'll then return.
I think it's Doc, help me out with some syntax here.
Oh, what's up?
If we're dict.value or dict.values?
I don't know what is dict.
Dictionary. Should
so
it
this is
be
actually stack.
care stack?
Is stack.items? Is that what you're trying to do?
Yes, I think that's what we're trying to do.
Okay.
Stack dot a single item.
Do that in line 13. And then you can do for index or for whatever character in stack.items.
Yeah, for char in stack.items. That's what you're recommending, right, Taja?
Yes.
That's correct. Yeah, that's it. Dot items.
Okay.
But you need to do the values in the.
Yeah, I think you have to do. I mean, I usually do like K comma V.
Yeah, like that.
Or let's just
Or
do
however you
that.
want to put it.
And then if val equals that, then return k, right?
There you go.
Yeah.
Yep.
Cool. So I guess that's it.
That's
How do
not
I-
bad.
How would I test this out? don't know
There
how to use
is
this.
a test single number.
Oh, okay.
Click play.
Well, I think you need to
What?
save it first. Well, you saved
Yeah,
it.
yeah, that's right. You got to make sure you save it.
You said hit play? Oh, I see. Okay.
Alright.
Invalid syntax. Oh.
Here we go.
Okay.
All right. All right, that's a first pass solution. Save that. We'll come back to it tomorrow.
Okay.
So the point of the first pass solution is to get something to work. Tomorrow we're going to look at it and see if we can improve this. What do you think? Is it improvable?
Well, it does ask for O of 1
That's right.
space complexity, so I'm assuming yes. This is O
All
of
right.
N.
Not bad. Well done. All right. Ed, you did a really good job. All right. Let's go to the... There we go. The specific README for moving zeros. There we
You
go.
guys see that? Is it like not too small? Or anything?
That is great. I love how you've got this set up. Looks like you've got a big computer screen.
Yeah.
Emmanuel, can you please read the instructions? Emmanuel's quiet. All right. Henry, there we go. Emmanuel, can you please read the instructions?
We can't hear you if you're talking.
If you're talking, your
Okay,
mic is
sorry.
on. There we go.
There. Write a function that takes an array of integers and moves each non-zero integer to the left side of the array, then returns the altered array. The order of the non-zero integers does not matter in the mutated array.
So, what do we know about what we're being given?
Array of integers.
All right, we're getting a bunch of numbers.
There's positive and negative ones.
Yep.
The order doesn't matter.
So it's unsorted. All right. Where does it want the zeros to go?
To the left.
I tricked you. Where does the zeros go?
Oh, my
Towards
bad.
the end.
Towards the right.
Zeros
Yeah,
go to the right. The
You move the
non
non-zero. Yeah.
goes to the left. All right. So
I mean, what's the
Rohit,
exact Python method? I mean, it's basically for I an array. I want to just pop or push it to the end, basically. I mean, if I equals 0.
right? So this you're going to want to take you're either going to want to take your 0. So in this, they want you to move the non-zeros to the left, or the zeros to the right. Moo-hoo-hoo. All right. Let's start thinking through this. Let's hear some ideas.
My initial thought is that if you encounter a 0, I just want to move it to the end of the array.
All right. So let's write some pseudocode. A comment is a hashtag. That's right. No, this is not Python. This is not the Python thing. Okay. So give me some pseudocode. What do you think? So if we see a 0, move it to the end. Okay, cool.
Could we possibly look for all the zeros and put them in their own group and then append them at the end?
I'm sure. We can do a lot of things. It's your first pass solution. I'm not going to tell you it's right or wrong. Might help with syntax a bit, though. So if we're going to use this solution, how are we going to do it?
Are we going with? I don't know who just spoke. I mean, if you guys want me to just type out, I can type out anything.
This is your solution. So if we encounter a 0 as we
Oh, that's
iterate
good,
through
mine.
the array, move it to the end of the array. All right. So how are we going to write that down? What do we need first?
I'm trying to think of the Python method that I want to use.
How do we iterate through an array?
You can use the list comprehension,
It's true. Ooh.
or you could use another. Somebody wrote a for loop. You can use one of those.
Yeah, I'm trying to think of the method that I actually want to use. I can't think of the top of my head. Like what would actually.
So you just want to grab it. So you want to remove and then pop it.
Yeah, I could just remove and pop it. Yeah. Is it literally just removed?
Array.remove 0. Array.append 0.
So it would just basically be array.remove I.
Yeah. If it's I is 0, yeah.
Is that basically it?
0.
The logic?
Oh
yeah.
0.
So just make it a 0. Yeah.
All right.
Is that gonna do like an infinite loop somehow? Let me see.
Let's find out.
Okay.
So then you go over to your test. Test moving zeros. There you go. And push play.
Yeah, it worked out.
All right.
Cool.
That worked out. I do think that it... I thought it would have created an infinite loop because you would have just been removing and appending and
Yeah.
Yeah, that's what I was thinking. I was like, this might do some weird stuff. But, yeah, then I think it's cool.
All right.
Not bad.
That's not a bad first pass solution. All right. Do you think we can do better?
When you just run this file, what does the output look like? Did you do that?
Yeah, he got all.
Yep. Okay.
Matches like they're reading now.
Yep. And it didn't create an infinite loop, which surprised me. So.
That surprised me too.
Why would you think it would create an infinite loop?
No, that was my first thought. Then I looked at it and I was like, nah, it should be fine. I think it.
My first thought was I was a little concerned that we were just going to get stuck on
removing and appending.
Yeah, removing and appending and removing and appending, but then
I thought it was that.
But then we did it. Then we did for number in array and not for I in range, and then everything was okay.
Ah.
So that's great. That's a great solution. Awesome. Product of all other numbers. All right. Henry, I haven't picked on you tonight. Can you read the directions, please?
Yeah, can you make that text a little larger? It's a bit.
Sure. Control equals.
How do you do that, by the way?
Control equals.
Awesome, thank you.
Yeah, that's good.
Excellent. Henry, please read the directions.
Write a function that receives an array of integers and returns an array consisting of the product of all numbers in the array, except the number at that index.
All right, so what do we know?
It's an array of integers.
All right, so one, we're going to receive an array of integers. Cool. What are we what else do we know?
We need to return an index, not the number.
No, we need to return an array.
Oh, I'm sorry. We need to return the number at that index. My bad. I misread that.
Return an array consisting of the product of all the numbers in the previous array, except for the number at that index. What index? What does that mean? What does that mean?
So we're multiplying everything in the array, but we're skipping whatever index we're at.
Given. Yes, that's exactly what we need to do. So we're going to have an array, a single array. We're going to multiply this number, the number at, I always start at 0, times every other number, except this one.
Gotcha.
Ooh, this one sounds fun. Everybody excited? Yes? All right, cool. So let's go over to the product of all other numbers. Let's hear some ideas. What do we got?
My first thought is for loop, but if you did do that, you'd get a O of n square solution. It's not so great, I think.
First pass doesn't care about complexity.
Yeah, but it's just stuck in my mind.
First
Yeah,
first
I
pass
hear ya.
doesn't care. Make it work.
Yep.
Your boss wants this done yesterday, and he will withhold all the lunchroom until you get it done, and you're super hungry. That seems like a terrible man to work for. Quit your job. That's the first pass solution. So, quick, dirty, and ugly. Let's make something. All right, we have a nested for loop solution. That sounds really awful. Let's make the nested for loop solution, Ed.
You could use a list comprehension.
Ooh. Let's make it the worst solution we've ever seen that works. Can we all get behind that?
List comprehension? They're still terrible to read, though.
All right. So we've got 10 minutes. I'd like you guys to solve this in 10 minutes, and we'll come back into the other room because we still have to make some cookies. All right.
I need ideas. I've only been to Lambda and
All right.
not anywhere else. So
Me
forgive me.
too, actually.
I'm thinking of like, I don't know, a while, like while you're at that specific array, you're going to.
All right, go ahead and type out that pseudocode, Emmanuel. That specific index is the word we're looking for, Henry.
Oh yeah, index. While you're at that specific index, you're going to multiply every other index in front of it. And I'm not sure how to exclude the index that you're currently at, but like,
Well, you still have to multiply the one before them, too.
Mm-hmm.
Yeah, so this one doesn't.
yeah. Okay.
All right. We hit a wall. Delete that one. Come up with another idea.
All right, how about just add everything into a different array except for what's in the index, what's at the index, and then multiply together what that second index or second array is.
Ooh.
Something like that.
You don't know how to exclude an index?
What do you mean?
So if you have an array
Yeah.
and you don't want to start at 0,
Mm-hmm.
can you start somewhere else?
I mean, you just change the range if that's what you mean.
Yeah.
But you would still need to start at 0 no matter what.
Do you?
No, because
Well-
you could tell it where to start.
And if we tell it where to start, we can assign a value to a variable. We can make a variable, guys.
Okay.
We can have a variable instantiated at 0, and then we can have it move.
Oh, you're talking about a pointer?
Yes.
Oh, okay.
I was trying to lead you guys there, but I felt like I was slowly creeping up my computer screen. So yeah, we can use a pointer. So what can we do with a pointer that's super cool?
Change it.
Yeah, we can change it.
Yeah.
So we can use a range and use the pointer to do stuff. Honestly, that's pretty good, gross, first pass pseudocode. Anybody getting anywhere? Do I need to look at my answer key and start giving really, really good hints?
So you
But they haven't
could-
even started yet. Slow
No.
down. Slow down.
I'm slowing down, but we got 10 minutes.
So I'm guessing you could start off a variable, something like array index equals 0.
Mhm.
And then have that change through each iteration, something like that. Just array index, one word. Yeah.
0.
Yeah, just 0. And then maybe an empty array, if that's the plan.
Just here.
Oh, next line.
Where?
Sorry.
Next line.
And call it just something else. Yeah, there we go. Something
Something.
equals array. Yeah. And then create a for loop, I guess, for I in a RR, and then semicolon, colon, yeah. If I does not equal,
If I does not equal.
is it I? Yes, I does not equal array index. I guess append. So it'd be something that append.
Aren't you, what are you appending?
Everything that's not I. Or would we need enumerate in this one? Could use enumerate, but I don't think that matters. Append. Yeah, go ahead. What were you gonna say?
If we enumerate it into a dictionary, we can keep track of the index. Yes, no, maybe so.
Yeah.
If you're in an array, you already have the index, right?
I suppose.
Or a list, rather.
So then we're appending ARR I in brackets. Yeah, inside there. ARR array. Or remove the brackets first. First ARR and then brackets I. And then I don't know what else to do now.
All right, so we have an entire loop that creates an array of every number except for 1. So I guess the next thing to do is go to this line. Go to a new line. So now we've done absolutely everything. We have to exit the for loop. Then what do we got to do?
Wait, you've done everything?
No, not everything. They've gone in the world. We've done everything in the world, Doc. So now we've gone through, we've added everything to the something array except for that one number, one time. What are we going to do with the numbers in the something array?
Multiply them.
All right, cool. With, I guess, another for loop. You guys are loopy. All right.
I don't know.
So first you need to return what?
Actually, I guess we probably don't need that line 14 then, because we don't want to append it. We just want some sort of total as we're going through this first for loop. So
Oh, that makes sense.
we can make another variable, something like temp.
Up here?
Yeah.
Up here or down there?
Yeah, up there. Mm-hmm. Wouldn't be 0 because everything times 0 is 0.
Would be 1.
Yeah, which is -1. So on line 14, we can get rid of that.
Oops.
Line 14. That's 15.
Sorry.
My bad.
Actually, 15 is the one. Yeah.
Well, it's 50. It used to be 14.
Yeah.
All right.
And then do. What's the syntax? Is it another thing times equals, right? So
Yeah.
indent once more. Oh, he's talking to someone.
Sorry, distractions here.
All right, cool.
What was the next?
Indent once more. Oh yeah. So you do another thing, and then times equals a array index. So ARR brackets I. Cool.
So.
Oh, sorry. Yeah.
No, this is not an index. This is the number. This is for number in array.
Oh, yeah, you're right. So it would just be I then.
Mm-hmm.
So that means that line 14 isn't even working because it's not keeping track of the index.
That's correct. So how do we go by index? Anyone remember? Henry. For I in
range.
Also, just going to suggest enumerate if you don't want to write the whole thing out.
In range length. So in range, parentheses. Len, parentheses. Array, close. No, array, R. And one more close. There you go. So this is how we do our index. We keep track of the index.
Cool. So now you can do array I. Cool.
All right.
And then finally, when we're done with the for loop, we can append it to something. So actually, no, actually, yeah.
In the for loop.
Well, it'll be after the for loop, but then now I'm trying to figure out how to increase array index. Because we want to do this again.
Yeah, array index plus equals 1.
Yeah, but I meant like to
Start
have,
at the,
yeah, start over again. Which you probably then need a while loop before the for loop, which will then make it that n square solution.
I was staring at my solution trying to figure out how to give you guys hints, but then I realized I did something really complicated, so I can't give you guys hints towards it. Sorry, guys. You're on your own.
So yeah, so just go ahead on line 16 and do something that append another thing. All right, so that just gives one solution.
All right.
And we need to iterate through this whole thing.
Now, this one's a bit tough. And how many of you guys remember? And by how many of you all, Henry's been to every single one of these. Henry, what is a place that where we can store things?
In
Starts with a B.
Ooh, I know.
What is it?
in a Boolean, or no?
No, gotta
No, think about a container. What kind of container?
Oh, in a bucket.
Yeah, we can put things in a bucket. Henry, do you remember how to put stuff in a bucket?
I don't remember off by memory, but let me open it.
Oh, think about it. You can do it. I believe in you, Henry.
Okay, I'll think about it. You would have to do you have to multiply, I think, by by zeros, and multiply the length of the array by 0, and that'll fill up the bucket with a bunch of zeros.
Close. We can multiply. We can do a list comprehension. I'll give you this one. Okay. On between 8 and 9. Here's your hint. Output equals list. Now give me a list. Double brackets. Give me double brackets instead of the word list. All right, we're going to initiate an empty list. Yep, brackets. 0. That was too many brackets. There. 0. 4. I. Well, 0. 4I. In range length array.
It's a list comprehension.
This is a list comprehension.
For the win.
So this is it. First, we did two things here that are really cool. First, we did a list comprehension. Does everyone, can anyone think of anything in JavaScript that's kind of like a list comprehension? A specific method, perhaps, that we do for each item in a list?
Oh, for each is not a list comprehension. That's just a for loop in Python.
It's kind of like.
Yeah, but that's different. Not. Yeah, so a list comprehension. The purpose of a list comprehension is to create a list.
Yes.
That's what it does. That's the only time you use it is when you want to create a list.
We're
A
doing
for loop, the for in Python is exactly like for each in JavaScript.
for I in range. So we're doing an action with a little for loop inside of a little list comprehension. It's when it's super, super short and easy. Though I have seen some pretty complicated ones. Doc, why do they get complicated?
Did you know there's also a dictionary comprehension?
It was exciting. But don't scare the people.
No, they should be excited about learning it in the future.
Yay.
We manage our fears.
This is me excited.
So what you're doing with this is you're just creating an array with a bunch of zeros. Is
right.
that right?
So I have an entire array and they're full of zeros. And the purpose of a bucket is trying to get Henry to answer. He comes to all of these. I know he knows it.
It fills them all with a bunch of zeros.
We've allocated a place in memory where we can store stuff. All right. We can store stuff for the future.
For the future.
For the future.
Now that you have this.
Now that you have a bucket, what are you gonna do with your bucket?
So you guess you don't need that. What is it? Something? You need something on line 11 because we're going to use the output.
Yes.
Bye-bye.
I don't need this one either.
Yeah, you don't need that whole line. So now we can, because we're going to have the same length of output compared to what we're iterating through on 14. So we do something like output I equals another thing.
Output I?
Yeah. It's inside the for loop. Actually, no, it's not. It'd be after the for loop. Okay. Yeah, so output I equals, no, output I? Sorry.
You were on the right track the first time?
Yep.
Is it still in the for loop?
It is.
Okay.
There's just no condition. Exactly what you said before.
Output I. Output brackets I.
Equals.
Oh, sorry.
To another thing.
Yep.
Yeah.
You are so right. You win.
Applying everything in output and we leave something as 0. Would we want those to be 1s instead of 0s maybe, or am I misunderstanding something?
No, that wouldn't matter because we're only replacing the 0. We're not actually manipulating the 0 in some sort of way. We're not adding or subtracting or multiplying or dividing that 0 in output. It's just a placeholder.
So now you want another thing. Get rid of your condition statement altogether.
Oh.
What do you think needs to happen here? What have you not done yet?
Well, we're not multiplying anything.
Yep.
Yeah.
So what are you going to multiply it by here? times equal.
To array I.
That's right. You're so good.
Though we don't want stuff that's I though. So
Yeah, you do.
I thought we didn't.
You changed when you added the range, I became the index.
Uh-huh. But I thought we were multiplying everything except that index that we're on. Is that not the question? Maybe I'm misunderstanding.
That's what I heard.
Yep,
It's like
everything but the index doc.
Yep, so if we're here, we don't multiply by 6 unless it's over here. But
Everything except for the index.
Stand by.
But you do have an accumulator, which is good. You've got a bucket. Very good.
Okay, so in this case, for each integer, we find the product of all the integers before it
And after it.
store
And after it.
the total product. Store the total product each time you go through the for loop.
I had to use 2 for loops. They were not nested, but I used 2 of them.
Did you do any division?
I did not.
Okay, just checking.
Though I think that might be my first pass solution. My first pass solution thinks to multiply everything and multiply everything by everything using a really, really nasty nested for loop. And then in another for loop, divide by the index.
Yeah.
That's what I would do for my really nasty, gross first pass solution.
Yeah. Okay. So what you did use division,
but not in my good solution.
Okay,
but
we're doing
really
first
nasty first pass. I don't know how I got some of what I have in my first pass.
Isn't that what we're doing? Is first pass solutions tonight?
Mine is gross. My everything is gross, and I don't even understand my answer anymore. But looking at it right now, my first thought is a nested for loop with a third for loop after the fact to divide.
Holy
Remember that
crap.
that's nasty first pass solution, Doc.
You called that one. You called that one right.
Yep. Nasty and gross. I have 1 minute to do it. That's what I'll do. I don't know all of Python off the top of my head. At the time when I wrote the solution, I didn't know anything except for loops. So that's what we got. There are other better solutions that can also be first pass solutions. But this is also the first problem in this set that starts getting complicated.
So could we do this or try this out?
Absolutely.
After 15, if you can make a new line. We're going to do this, I guess, the same thing that we were doing before. Where if array index equals I. Oh, let me see if this works. Yeah, the second one. Yeah. Equals I.
Just I or brackets?
No, just I. And
1 equals 2 equals.
2 equals. Yeah. Okay. And we're going to continue. Or do the what's it called? Colon? Semicolon? Gotta look it up now. Continue. And then space or enter. else, and then indent line 19. Or get rid of that line, but indent the another thing line.
Oh.
Cool. So we have that. And then if you make a new line,
In the else, in the loop.
actually, sorry, put line 15 after the for loop. So move line 15 all the way to the bottom.
Oh.
And then get rid of indent, one indent. Cool. And then create a new line on 13. Cool. Go down once. I'm thinking about making a while loop. So while the length of the array. And then I guess we're gonna need a counter to keep track of the array. So on line, you can put it on line 12 and a half.
12 and a half?
Yeah, so after 12. That's what I end up saying sometimes. It makes sense to me.
Between line 12 and 13 is what you're trying to say, right?
Yeah.
New line,
Well,
12
after,
and a half.
Yeah.
Yep.
Make a counter equal to, I guess maybe 0. Let's do 0 for now. Yeah. So now on line 15, we could do while counter less than or equal to length of array, I think.
Less than or equal to?
Yeah.
Have not encountered this.
Yeah. Just an equal sign. Less than.
Oh,
equal.
less than or equal to. Okay.
Yeah. Okay, cool. And then indent the whole for loop.
And there you go.
So from 17 and 22, indent that whole thing. Yeah. Cool.
Wonderful.
And then at the very end of the for loop, right after that, yeah, do count plus equals 1. Cool. And then just at the very end, return output.
Out here, right?
Yeah. That's what I'm thinking. I don't know.
Doesn't know what count is.
Oh,
or
because you.
counter.
Yeah. Cool.
And this I is possibly unbound, but don't take my word for it. Because this I is part of the loop.
Yeah. So I guess you would need a for loop instead of a while loop then to keep track of that. All right, let's do that instead. So instead of a while loop, to another for loop. The dreaded double nested loops.
For?
Yeah, for I and range length of like before.
Length of what?
Array, yeah. So you can get rid of everything else after that.
Range. I know we're all mad
I'm
at code
channeling-
sometimes.
Yeah, my subconscious is typing. So
And would it be length of array minus 1?
we need to change. Are we doing for I twice?
Oh yeah, so make the i's into j's inside of that for loop.
Or you could do, I guess, what comes before I? H? That's... Yeah, you did it backwards. That way just you don't have to change as many things.
oh, you're right.
I'm pretty sure that's not like the best plan, but...
No.
Oh,
then-
no, it's purple. Why is it purple?
Hmm?
Is that H purple
No,
or
it's
am I...
gray.
Yeah.
Okay.
So then on line
Then just
22, you
line.
could make that into h.
And then it'll know what we're talking about.
Yeah.
Yep.
Okay, I don't know. Let's try it out.
All right.
Oh, it's ugly.
And we got the bucket leftovers.
No, what? We got the bucket left over. Oh, we didn't remove from the bucket.
All the leftovers. Oh.
Oh gosh. Ah! So what did we? What did we do? Got a lot of zeros.
Yep.
Woof.
Ooh.
Woof. Got a lot of zeros. What do we do with all those zeros? Can we go to the very beginning of this answer? Just, yeah, all the way to the, okay. I have a feeling that's not the answer. Is that the answer?
You know what? I think this is multiplying 2 times 6, and then multiplying that times 9, and then multiplying that times 8. What is the answer supposed to? No.
Let me run. Let me run. That was my eating cookies test. I want my product of all other numbers tests. So if you run the unit tests, I have what they expect. So that's a good way to start. Let's go over to the unit test. So click on the test for the product of all numbers, and then click play.
Yeah, I did.
Alrighty.
We got
So,
all the...
wow, that was the test of all the other numbers. Oh my goodness. Well done. So, this is what it expected.
It's nowhere near.
This does not...
It's off by a few zeros.
Yeah. And also, the beginning of it. Just do me a favor, click the play button on this page.
Let me...
Yeah, clean that out.
clear it.
Then just push play on this page, because I think you might have pushed it on the other page. There we go.
Oh, okay. I guess it wasn't
There you
that
go.
many.
There we go. So we can see 9 times 90. First, so we can see this. Ah! 9 times 90 should be this. Okay. What did we get?
A 90 and a 9? I don't know.
99, 9 and 90. Scroll down a little more.
That's it.
All right.
Just a failure.
Okay, 9 times 90. So if we don't have a number, did we instantiate the another number at 1?
Yeah, I'm pretty sure we did.
Okay.
Oh, it's
Oh.
not even passing. So does that mean that we're not resetting another thing to 1?
I
Is that
think
what it could
so.
be? Yeah.
I think that's the thing.
So at the very end of the for loop. So after that, yeah, let's put another thing equal to 1. Maybe. You guys try that out.
Try it again. It's less and more organized this time. Let's try it. Let me make it clear. And
Close.
Closer. You're getting 90 and 9. What are we doing with? What are we doing with that? Are we replace? It looks like we're somehow adding a 0 to the answer. How is that happening? Times equal another array. Put another thing. You know what we could do? We can get rid of this list comprehension. And then we can have output dot append another thing. So we keep the output, we just make it an empty list. And then let's just try output dot append another thing.
hi.
Let's give that a shot. Let's see if getting rid of all those zeros was helpful. Nope. Somehow ended up with way too many zeros.
How do you know there are too many zeros?
I don't know. It's a good question. If we run the other test, there was extra zeros.
If you run the other test?
Yes, the tests. He was running this one on
Yeah,
the
'cause
product of
it's-
all other numbers instead of the test product of all other numbers. So if you run the test, the unit test,
Mhm.
then it looked like there was an extra 0 in there. All right. My initial thought was that somehow I had set this up wrong and we were getting zeros where we didn't need to have zeros.
Yeah, there are a lot of zeros in the answers.
Why?
Because they're big numbers.
Which is a good
We're
point.
back.
This, I mean,
Can I'm not going to show you the optimized solution because I know that's for tomorrow night, but can I just show you what the output should look like?
Yes.
Let me put this in Slack so that I can format it.
All right. We have 8 minutes. I am still trying to stare at my solution, trying to figure out how I can give hints, but our normal players know one thing about me, and that is that I am bad at math, so I can't even nudge.
So creating this this output that you see on the screen, I do pass the test. So oh, what did that happen? Why did that happen? I had them in a single line, and now they just when I made my Slack bigger, they spread out. I guess it wasn't formatted the way I thought it was.
Slack is kind of mean about their chat. I mean, that's Slack. So there are the proper number of zeros.
Yes.
We were just getting the exact same first number every single time.
Oh, well, no, that's not helpful.
Wait, so what happened? Was the solution okay?
Well, entertainingly, somehow we are getting the first number twice. So we're going to, if you have 90 as your first number, we were getting 90, 90, 90 ad nauseum. So how do we fix that? So if array is equal to I, that's looping. This is other thing times, right? I depend, another thing. We're resetting another thing. Counter goes up. Where are we using the counter?
I guess
I
not anymore. We could get rid of that because it was for the while loop.
Okay. Go ahead and run that big test again. See, we have the same number. Your first solution is getting appended every single time.
Oh, I see what you're saying.
How many times is it?
Look at the output that I posted in Slack.
Oy.
That's what it should look like.
Oh,
So we
that's
should
what
have-
it should look like.
We should have 1585, et cetera, et cetera, et cetera, many, many zeros, followed by 5285, something, something, something. But if you look at our output, we have 1585, 680, et cetera, et cetera, et cetera, every single time. If we look at this, do you see that we have the same series of numbers almost every single time? Yes, every single time. That is the same number.
Mm-hmm.
So, why are we getting the same number every single time?
$1,000,000 question.
Can we blame it on the test?
You cannot, because I used the test on that set of numbers that you just saw, and I passed.
Dang it.
So, what if this is just me, but I would have done if array index is not I, continue. You're not increasing your array index. That's what you're not doing.
True.
So your counter should have been your array index. You're not increasing your array index. So after your another thing goes back, so down on line 23, array index plus equals 1. And then you can do if array index strictly equals I. All right, see if that changes anything.
Let's
there you go.
clear it.
That's
Run the
It's all-
test.
you have
all
to go to
different.
the tests. All right.
Nice.
Ta-da!
Was it keeping track of the index?
Here we go. So
Got to increment the index. The eagle eye. That's a good call. Good catch. Good catch, Ava.
yeah, that is my strength. It's definitely not math. So what did we learn from this, guys?
I'm in over my head.
No.
So say we all the time.
Yes. So say we all.
So what did we learn from this?
Keep track of variables that need to be
It's
kept
important to
track of.
have what kind of variable names?
Descriptive
Good, descriptive, explicit variable names.
Mhm.
Yeah, so whoever came up with another thing, clap yourself.
That is what we've learned.
Yeah,
We need
I just totally
explicit-
forgot about the index too as well.
You had an index up here. You had a
Yeah.
counter, and then
Mhm.
you also had a counter underneath it. So what did we also learn the importance of? Commenting your code.
Hmm.
When you're going through these solutions, especially on Code Signal, especially for the GCA, write out what you think each thing is supposed to do, because the amount of times that I've looked at my code and gone, oh, this isn't doing what I thought it was doing. So if you write a little comment, what you think what it's keeping track of, what it's doing, that helps your brain. So I noticed that we had a counter down here that was increasing, but we weren't using the counter up here. Then I looked up here and saw we had an array index then that we weren't using in here.
Yeah.
So really good job, guys. Do you think we can do this better tomorrow?
We'll see.
Maybe.
I think we can. Doc is going to explain this one to you because it is a Fibonacci sequence.
No,
which
it's
is
not.
like, are you sure?
Yep.
All right, because it's awful and I hate it. So Doc can explain it.
Yeah. Okay, zoom in. Okay. So when we look at the problem, the first thing that we want to identify is the input. So what is the input here? Go back to the README. We're going to stay there for a minute. We're going to read this problem because this is what trips everybody up, is not reading this problem.
Okay. A Cookie Monster can eat either 1, 2, or 3 cookies at a time. If you were given a jar of cookies with n cookies inside of it, how many ways would he eat all n cookies in the cookie jar? Implement a function eating cookies that counts the number of possible ways Cookie Monster can eat all of the cookies in the jar.
Yep. What's your input?
Would it be n?
It's in cookies, right?
Yeah.
So I mean, in this kind of in a narrative, we're going to say it's in cookies. But yeah, you're right. I mean, technically, it's going to be in. Okay. So what is your output?
Eating cookies. Or no, that's you're gonna, okay.
How many ways he can eat the cookies?
Hey.
I'm trying to think through this one. I hated this one, Doc.
Okay. How many ways can he eat the cookies? That's what we're after. And that's going to be, we're dealing with numbers here. What is that in the, oh, yeah, we're doing a first pass solution here. So we're not caching anything.
I put
Okay.
a cache in my first solution.
Well, you're weird.
I
Okay.
know.
So in cookies is the input. How many ways is the output? And what is the how are we, what are the steps that we know that we need to take? And don't look at this.
Okay. Well, shouldn't we do a counter?
No,
So that way, oh,
you already have a counter, basically. So you can eat cookies either 1 at a time, 2 at a time, or 3 at a time. Okay, so if I have in cookies and I eat 1 cookie. Now how many cookies do I have?
2.
You have n minus 1 because you ate 1.
Yeah.
Does that make sense? Do you see that?
A little.
Okay, so you have n total cookies. If you eat one of the, I mean, think of a literal cookie jar. You've got a cookie jar. You don't know how many cookies are in there. You take one out and you eat it. Now how many do you have left?
Whatever is left, like 2.
You don't know how many cookies are in there.
Remember, there are n cookies, an unknown number of cookies.
Yeah, you got a big old cookie jar. There's a bunch of cookies in it. You eat
Oh,
one.
okay. I see.
You eat one. Now you got n minus 1 cookies.
Right.
So if you eat, another way that you can eat cookies is to eat 2 cookies at a time. So if you eat 2 cookies, how many cookies do you have left?
N minus 2.
N minus 2. What about if you eat 3 cookies?
N minus 3.
N minus 3. So what's the other option that you could have? Don't eat no stinking cookies.
Oh.
1, 2, 3, 4. Now, what else do we know?
We know that we should track how many times we should track how many possible ways he can eat the cookies.
Right. And how would you do that?
By
Isn't that what this is? So if I don't eat any cookies, I've got to start with n cookies. If I eat no cookies, then that's one way. If I have n cookies, I got a big old cookie jar with a bunch of cookies in it. Don't know how many there are, but I can eat 1 cookie. That's one of the ways that I can eat. Then that is also a way. If I can eat 2 cookies at a time, and I subtract those 2 cookies that I ate from however many there are, that's another way to eat cookies. And then if I eat 3 cookies and I subtract that from whatever number of cookies there are, that's the 4th way to eat cookies.
okay.
What are you drawing, Ava?
I'm keeping track. It says he can eat 1, 2, or 3 cookies. It didn't. You 0 cookies is a way.
Yeah, it is.
Let me look. It is.
I shall show you shortly.
N minus.
Okay, and what about this? What does that say?
Thus, eating 3 ways of eating cookies should return an answer of 4, or should return 4 ways.
Right. So if you've got this function eating cookies and you pass in a 3, what is that 3?
Uh, the 3 cookies are
Yep. So how many cookies do you have?
what?
So if we're passing in the number 3 to our eating cookies equation, how many cookies do you start with?
3.
How many
So
cookies do you have?
your N is 3. Right?
Right. Okay. Okay.
In cookies,
Okay.
you just so we say that generically they're in cookies, but this call of the function tells us there are 3 cookies, which is kind of handy since the number of ways that we can eat cookies is we can eat 1, we can eat 2, we can eat 3. So that's really kind of tidy. Yeah.
Yeah. Yeah.
Okay. So now you do it. Nope. Go back to the README.
Explain the cookies.
Yeah.
Oh.
That's even more explicit right there. N equals 3.
So the Cookie Monster has 3 ways of eating cookies in the cookie jar. And depending on how many cookies there are, there's going to be an output of all the ways that he can eat the cookie. So if it's 9, all right, no. If there's, oh, that's too many.
Okay, so wait, let's go back a step. What's your input?
The number of cookies inside.
And what is that? Starting at the top of this problem up here, what is the number of cookies?
And
okay, so you would expect your function to start out with eating cookies with n passed in, right?
Right.
Okay. So now, what's your output?
How many ways he can eat all of the cookies?
That's right. That's your output right there. So how many ways can he eat the cookies?
He can eat it. He can eat the cookies depending on n number of cookies inside.
Okay, read the very first sentence in the problem.
He can eat it either 1, 2, or 3 times.
He can eat what?
He can eat the cookies either 1, or 2, or 3 times.
You mean at a time?
At a time, yes.
So he can eat 1 cookie, he can eat 2 cookies, or he can eat 3 cookies. And technically we know that he can also eat 0 cookies. So if he eats 1 cookie, how many cookies do we have left?
N minus 1.
And why is that?
Because we don't know how many cookies are inside the jar, so we write down n representing the mysterious number of cookies.
Yeah, so our input is in cookies. You're right, we don't know how many cookies we have. So if we eat one cookie, then we have n minus 1 left, right?
Right.
Okay, so if he eats 2 cookies, how many do we have left?
N minus 2.
N minus 2. And if he eats 3 cookies,
N minus 3.
okay. So in terms of the number of ways that he can eat the cookie, do you see how this works? So if he can, controlled by the number of cookies he can eat at a time, right? And
Right.
also the number of cookies that we pass in, which is 3. We have 1 way to eat cookies. We have 2 ways to eat cookies. We have 3 ways to eat cookies, and we have 4 ways to eat cookies. That's where you get this number.
Okay.
Okay, now, in order to determine how many cookies we have left, we're doing the same thing, the same calculation, subtraction over and over again, right?
Right.
So if we have identical subproblems, what does that lead you to think that we can do in order to solve? What pattern is this that we've been working with previously that we can use to solve this problem? Identical subproblems.
Um,
Can you Google identical subproblems and see what you get? I don't know what you're going to get. I'm just curious.
okay, hold on.
Identical subproblems.
There's dynamic programming.
Is that it?
Yeah, that's what all of them mainly say. Divide and conquer.
No. Okay, how about adding Python in front of that? Will that do it?
I did.
Oh, okay.
And most of them just say dynamic programming or overlapping subproblems.
Okay. What does overlapping subproblems say?
It can be broken down into subproblems which are reused several times. For a recursive algorithm.
Yay!
So we're going to use recursion.
We are. Because we have identical subproblems.
Okay.
Okay, so let's go to the code. Excuse me. Okay, what do we know? What do we know about recursion? What are the elements of a recursive solution?
We need a base
The base case. Yep,
base case.
100% right. So because we're not told that we don't have any, it's impossible to eat negative cookies, right?
Right.
So just to be very thorough and cover that edge case, we're going to say if n is less than 0, just return 0. Now, here's our actual base case. And we're going to do this as an elif. So what are the circumstances that you can no longer eat cookies?
If n is equal to 0.
You are so right. So n double equal. Yep. And in that case, if n is equal to 0, we're going to return 1. Now else. Return. Now here's where we recurse. So we're going to call the function. And what's the first way we can eat cookies?
One at a time.
Yeah, so how many do we have left?
N minus 1.
Right. So do you see why we put n minus 1 there?
Yes.
Okay, so we pass in n cookies. Our base case is for n to equal 0. And we have to move toward the recursion is required to move toward the base case. And in this case, we're going to eat 1 cookie, so that's n minus 1.
Right.
Okay. And then, yeah, now we're going to add to this the other way that we can eat a cookie. Yes. And then we're going to
add the.
then we're going to add the last one. Why do we stop at 3?
Because Cookie Monster can only eat 3 at a time.
Right. That is correct. And for this is considered a first pass solution. Miss Smarty Pants over here has got a optimized solution, but she needs to hold her fire until tomorrow night. So let's see what happens when you run the test. Whoa. Type error.
Do you have to wrap the Yeah, double parentheses around that. So,
Wait, what?
Because if we don't do it, then it would just say like too many operations are happening, right?
it started yelling at us for that recently.
Is that something new in takes one positional argument, but two were given? Oh, get rid of those spaces, dude, and get rid of those. It thinks those are
Okay.
two different.
Yeah.
And get rid of those double parentheses too. Two, where is it finding these two positional arguments?
Ooh. Ooh. Hmm. Hmm. Hmm.
Num is equals 5.
It should be totally fine with what you're doing.
I know. I think the test might be problematic. Okay, so where is it? Takes one positional argument, but two were given. Oh, this is coming from the test. Self-assert, eating cookies, 50, comma. I don't even know what the hell that is.
The second part is the answer. This part's the answer.
Yeah, yeah.
But the list comprehension, I don't know why it's there.
Yeah, that's what, yeah, I'm not worried about the last part.
Hang on, let me look at my tests.
Does your test have that?
It does. And it doesn't, it's not bothered by it.
Okay, so do we have a typo here somewhere? Let's go back to the code. Make sure we've got all of our semicolons. We got our double equals.
But
I don't see a typo.
self-assert, testing cookies small, testing cookies large.
All our tabs are good.
My eating cookies was modified to take 2, however, because mine uses a cache and I pass in the cache.
Yeah, but that's we shouldn't have to do a cache in order to get this passed. This is like this code is correct.
I know, but I'm still telling you that is I did modify it to answer.
Yeah, shoving an algorithm in a data structure is always good for code challenges, but it shouldn't be needed for a first pass. Okay, so are you saying that this thing won't pass without a cache?
I don't know. Henry, just do something really silly. Add n comma x. There.
That's annoying. If that fixes it, that's really annoying.
That fixes it. It's really dumb.
It made it worse.
Okay.
Wait, don't wait. Eating cookies is one positional argument X. Yeah, take that out. I'm going to try something real quick. And it's going to piss me off if it works.
Mm. My Pep 8 says eating cookies is not callable. And also that one of my lines is too long. But it's still runs.
Eating cookies is most certainly callable. A function is callable.
It gives me a little orange line and it fusses, but it still works, so I don't really know what's going on with the eating cookies thing. When you go to your test eating cookies, Henry, hover over the red squiggle. Too many positional arguments for a function call.
Integer returns an integer. Too many positional arguments for a function call. Okay. Wait. Go back to your terminal. Okay, and type in Python space -v. Oh, that's okay. Create running. That would have been nice if it had been that simple.
Can we just go with this solution works because we know it does for a fact, and the test is just evil?
Yeah, I'll be up the rest of the night trying to fix the test, though.
To be completely fair, that's kind of what's going on in my labs.
What are the red squigglies here on eating cookies? What is that? Yeah, this stupid what do you call it? List comprehension is the problem.
But mine works in mine.
Okay, so go back to the and up here where it says eating cookies at the definition of the function, put a comma after the N and type that's not gonna work.
Mine has cache equals empty dictionary.
Okay, type that in. Cache equals empty dictionary. Yep, now run it.